So this is your formula sheet. This is the sheet digitally that you get every time you take a test, every time you take a milestone, a district exam, anything like that. And so this, when you're studying for your milestone, mostly what you're going to be studying is this sheet. And we're going to be taking notes on this sheet. And so first, do you guys see where it says linear equations? Right here.
Yeah.
Cool. See underneath it, it says arithmetic. Right there.
Yeah.
So linear, today we are learning two new terms. We're learning arithmetic and geometric. And so see how linear and arithmetic are right next to each other? They are the same thing. Linear functions are arithmetic sequences. Then we go down a little bit and see how it has exponential right here and has geometric right there. Those are the same thing. And so if they use those words, geometric or arithmetic, they will. This is on your milestone a lot. Like every year, most students come back to me and go, wow, there are a lot of arithmetic and geometric. But you get the sheet the entire test. So in case you forget, oh, geometric means exponential, arithmetic means linear. You don't need to memorize it because you'll always have that sheet. So make some little notes, whatever you want to do, color code it on your sheet that you have in front of you. Yeah, you're writing on that. That's yours. So you can color code, highlight. You're just showing yourself that arithmetic and linear are the same, and geometric and exponential are the same. So you have that sheet right in front of you. You took that sheet up there. You did. So make sure you grab it. And so these look a little complicated. That is what we're doing tomorrow. So don't worry about these formulas. We'll be dealing with those tomorrow. Today, what we're going to be learning, which is part of this, is the D, the A1, and the R. Those three things are what we're going to be learning today, what those are. Cool. Did everyone make a little note on that sheet? Great. So now you're going to go to your notes for today that are like this. It's a little half sheet of paper, and it says types of sequences. So the first are arithmetic. And so what that means, we were using tables and stuff. Now we are using sequences, which means you're writing numbers. They're basically a group of numbers written together. So make sure those phones are away, make sure headphones are away, hoodies are off, and we're writing these notes down. The notes are already on the board. Oh, yep, the notes are already on the board. So arithmetic, which is linear, right? We already, linear and arithmetic are the same thing. Which you went over the do now. Linear was a sequence of numbers that have a common difference. So that D, difference, is what we're focusing on. Or the same number being added or subtracted. We have learned before that difference means subtraction, right? But difference in this case, the common difference just means what's being added or subtracted each time. So common difference, which is your D, is what's being added or subtracted each time. So let's go over some examples. 5, 10, 15. What comes next? 20. How do you get that? I added 5. So my D, my difference, is plus 5. My common difference means I'm adding 5. Let's do another one. 60, 58, 56. What would be the next one? 54. How do you get that? Perfect. My difference would be minus 2. Last one, negative 2, negative 5, negative 7. What would be next? Oh, that wouldn't make sense, actually. Negative, I'll make this negative 3, negative 5, negative 7. What would be next? Negative 9. What is our difference there? Subtracting 2. So we got to remember when it's negative, I'm taking 2 more away. So those are my 3 examples. And so the first part of today is you're just differentiating between arithmetic and geometry. Yeah. sense what arithmetic is. All right, so geometric is the next one, and here's the next definition. And so we remember geometric from exponential. So geometric is multiplying over and over again, and we call that a common ratio. So now we're going to be talking about R. So common ratio is when it's geometric. If it's arithmetic, it's different. I'm going to shut off my light. So geometric is a sequence of numbers that have a common ratio, but the same number being multiplied. So basically, that growth or decay factor, that is your R. And so let's do some examples. I'll do 1, 3, 9. What would be the next one?
12.
No, it's 15.
Huh? It's 12.
13. 12.
Isn't it going by threes?
18.
Is it adding or multiplying?
Multiplying.
So what's 9 times 3?
But 3 times 4 is 12.
What?
Good point.
3 times.
No, that's a good point. Because he was thinking,
What?
okay, 3 times 1, 3 times 3, like he was using this number.
Yes,
Yeah.
And multiplying it, but it's to the one before, which is a really good point. I'm glad you said that. So we're taking the term before and then multiplying by 3. No, it wasn't a silly mistake. It was something that I wanted to happen. And so our ratio would be what?
3.
3. Cool.
I was confused.
Y'all got me thinking.
What about 20, 10, 5? What's happening there?
Decreasing.
You're dividing. So what would that be multiplying by?
What's wrong with you?
What did you say there? 1/2. So remember, if you're dividing by 2, you just flip it. So you're multiplying by half. -3. No. Yes. -3, 6. -12, 24.
What? Oh, you're adding my you're adding my score.
No, she
You're multiplying by
negative.
-2. I thought about it. Because -2 times -3 is 6.
And then negative.
6 times -2 is -12. So see how the signs are flipping? That's because we're multiplying by 6.
I was say -12, but that's not how to say it.
Neither would be like nothing. There is no, like, if I had 1, 5, if there was no common theme. So you don't really need to fill out neither. I don't really care about that. So now you're going to take a few minutes, and there's another half sheet that you took that looks like this. That right there, do you see it? Yeah. And so all you're doing is you're writing A if it's arithmetic, G if it's geometric. So what did I use for A? So it's either arithmetic, geometric, or neither. So, for example, let's look at the first one. Oh, wait. But like, if you, what's 1 plus 2? 3. What's 3 plus 2?
6.
5.
5. So it's not arithmetic. What about 1 times 3 is 3? What's 3 times 3? 9. 9.
Wait.
Neither.
Neither. Did we do neither?
Neither of these. Neither of these. It's not adding or multiplying. So like 4 to 16. What would I do? I can either add 12 or multiply by 4. What's 4 times 4 is 16. What's 16 times 4? What's 64? So what would this one be then? Neither.
I'm gonna put N in.
So it's either multiplying, adding, or subtracting. If it's not, it's neither. So like right here, and actually, well, right here, not right here. So 1 to 4. You could multiply by 4, but 4 times 4 is not 9, right? So it can't be multiplying. What do I add to get from 1 to 4? 3. What's 4 plus 3?
3. I mean.
What?
7. Is that 9?
It is.
Wait, what? Most of them are
Because this pattern is actually just, they're making weird patterns up. Like this one's 1 square, 2 square, 3 square, 4 square. If you see that, 5 square. That's not geometric curve.
Are these on?
not
What about this one?
No, that's geometric.
No, you multiply
3 by 3. It's arithmetic. Wait.
Why?
Because,
Because you, what's your difference? You add what?
3. Oh, I knew how to do it.
Yeah, so plus 3, plus 3. So you're going through and just labeling it A, G, or neither. And if it's A or G, tell me what the difference or the ratio.
Yeah.
So see if you can try that on your own.
Yeah.
Shut up.